Hi everyone. We're going to start our next chapter and it's going to be about thermochemistry. So our learning outcomes for this chapter are listed right here. So we want to make sure that we can define and distinguish between different types of energy and describe the nature of energy changes. We want to think about the differences between heat, thermal energy, and temperature. We also want to define and distinguish between specific heat and heat capacity and describe the kind of calculations and implications of those. We also want to spend a lot of time with lots of practice on how to perform those kinds of heat capacity type calculations. And we also are going to work towards looking at calorimetry and how we can do the calculations to understand how our reactions work. So thermochemistry is all about how heat is absorbed or released during chemical and physical changes. So thinking about our moles of A going to moles of B, we've already looked at this kind of transformation and looking at stoichiometry. And using our balanced chemical equations. But what we're going to do now is we're going to do a little sidetrack over here. We can also understand how heat moves in between our reactions. So how heat moves and all of our thermochemistry. So here are some definitions that we are going to use for today. Energy is the capacity to supply heat or to do work. Work is a very important concept for thermochemistry because we are going to cause some sort of matter to move against some sort of force. So we will see this quite a bit. You may see a gas that's expanding against a piston, but in most cases, we're looking at the kind of work that our chemical reactions can do, particularly with things like redox reactions. Kinetic energy is sometimes illustrated with a KE on here, and this is all the energy of motion. So when things are moving around, what kind of energy? Potential energy is where we start to think about energy by position. So just by how a system sits at a specific time may have some sort of energy. So we're thinking about things like storage of energy. So something that comes to mind are things like batteries. And also, if you have some sort of object at a higher level, so before an object actually drops, it has potential energy. So the last concept that is really important and really the crux of what we're doing in terms of this section's work is the law of conservation of energy. And this is where energy can only be transferred. It can't be created. So that is what we're really going to look at in terms of the work we're doing in this section, is how our different energies are going to transform based on our chemical reactions.